So hello Level 2 physicists, NCEA, and today we're going to be looking at forces. Okay, so primarily been looking at motion for most of the term. Today we're going to move on and look at forces. So first, what is a Newton? Okay, so a Newton is a unit of force. So 1 Newton equals a kilogram times meters per second. And 1 Newton of weight is in this apple, for example. So in terms of Newton's first law, states that a body at rest or moving with a constant velocity will continue moving at rest or constant velocity until acted on by an unbalanced force. Okay, so think of that analogy as you on the Monday. Okay, you won't get out of bed until you're acted on by another unbalanced force. Your caregiver saying, time to go to school. So in terms of Newton's first law, what is this net force? Well, the net force is the sum, again, of vectors, which we all know and love, of the forces acting on an object. Okay, so if you look at this example here, you have 20 newtons plus 10 newtons on the left, so 30 newtons in total, and 8 newtons to the right. So the net force, and force being a vector in this case, is 22 newtons to the right. Okay, so 30 minus 8. So when all the forces on an object cancel out, we say that the object is in equilibrium. That's when the net force equals 0 newtons. So you see that in the example here, there's 20 plus 10, 30 newtons on the left, 30 newtons on the right. The two cancel out, so the net force is 0. So when you're drawing free body diagrams, there's 3 steps you take. You draw the object, or box, or dot, all by itself, alone on the page. Then you draw the vectors starting from the center of the mass to represent all the forces. And you label those forces with a description. So it could be the force of friction, the weight force, the thrust force, the normal force, depending on the context that the free body diagram is being drawn in. Okay, so in terms of types of forces, one of the most common ones is weight force, which is going to be mass times the acceleration due to gravity. Okay, well actually it's gravitational field strength, I tell a lie. G is the gravitational field strength. So on Earth, the gravitational field strength is 9.81 meters per second. Okay, mass will be in kilograms, and the weight, of course, will be in newtons, which have the SI units of kilograms, meters per second. Then, so you also have an appreciation of the difference between mass versus weight, because in common language, weight has the same connotations as mass, but in physics they have different meanings. So mass is how much matter, or the amount of matter you have within a certain volume, okay, and it has the units of kilograms, whereas weight is the force on an object due to this gravitational field, okay, and that has a weight being a force. The units are Newton. Another kind of force is going to be tension force. Okay, you can see on the 2 images there. So on the first example, you have the weight force of the bird going down, and the tension forces will be equal and opposite in direction. Again, that's a vector, so they will be on an angle. Okay, and in the case of the pulley system, you have the weight force going down of 100 newtons, but you have the tension force, which is equal and, well, actually, that's going up. The tension force at least going up. Okay, so it won't necessarily be equal and opposite, depends if it's in equilibrium or not. So which ropes support more weight? Okay, so both kids are in equilibrium, so the net force will be in 0. So the first kid will have, the rope will be holding 200 newtons, okay, because it'll be in equilibrium, whereas in the second example, each of those ropes will be holding 100 newtons, because 100 newtons plus 100 newtons equals 200 newtons going up, which balances the weight force going down. Another type of force is the normal reaction force, which people sometimes forget, and that is going to be always perpendicular to the surface. Okay, there's going to be right angles to the surface. Okay, so you get the weight force going down, and you have the normal reaction force going up. And because that ball's not moving, then it's going to be equal and opposite. And then you finally have friction. Okay, so here's an example of Sunny Bill taking a tackle. Okay, so you've got that thrust force of the tackle, and then as the tackle wag rubs against the surface of the field, it's going to have a friction force acting in the opposite direction. Okay, so those are the major kinds of forces that you'll be interacting with in this standard.